In this video, we're going to be looking at graphing inequalities. So let's start off with the inequality y is less than 2x plus 3. Now there are two steps to this. The first is that we have to graph the boundary between the three areas of the graph that we saw before. The part of the graph that indicates y values greater than the function rule, the part that shows y values equal to the function rule, and the part that shows y values less than the function rule. So we have to graph that part first, and then we need to shade in the appropriate region. So in order to graph y is less than 2x plus 3, we start by graphing the equivalent line, y equals 2x plus 3, just like we normally would. And we know this is in slope-intercept form, so I know the y-intercept, the location where this crosses the y-axis, is going to be positive 3. So I start by just drawing a point at 3 on the y-axis. Now from there I need a second point, and the only other information I have is the slope. So given that the slope of this function is 2, what I'm going to do is start at that point that I've drawn, and for every one space I go to the right, I'm going to go up 2 spaces, because recall, that is the meaning of slope. Now if I want more points, I can certainly add them by going right 1 space and up 2, or if I'm out of room in that direction, I can reverse those directions and go left 1, down 2. Either one works. But for a line, I really only need 2 points. So now what we're going to do is we are going to draw that boundary as a dashed line. Now I'm on a computer, so I can just press a button and make this happen, and it's perfect and beautiful. If you're doing this on paper, use a straight edge. Find a ruler, the edge of a clipboard, something that is nice and straight and rigid, and make this look good. And remember, we're filling it in with a dashed line. So now I have my boundary, and that boundary defines my 3 parts of the graph. The part where all the y values are greater than 2x plus 3, the part where they are equal to 2x plus 3, so again, every point on that now solid line, the y value is equal to 2x plus 3, and the region where the y value is less than 2x plus 3. And this is in fact what we're interested in. So what we're going to do is exactly what you see on this graph. You're going to take your pencil or colored pencil or marker or however you're going to do this and shade in that region that indicates the area where the y values are less than 2x plus 3. And there you have it. That is your graph that you are looking for. We've graphed the boundary as a dashed line, and then we have shaded in the appropriate region. Now we're going to do this again, but instead of looking at an inequality written in slope-intercept form of a line, we're going to look at an inequality that's written in standard form of a line. So I have the inequality 2x plus 3y is greater than or equal to 12. So just as before, the first thing I have to do is graph the boundary, and the easiest way to do this is by finding the intercepts. Now remember, the intercepts are the places where this runs into or intercepts or touches, however you want to think about it, the x or y axis. So let's start by finding the x-intercept, the location where this function crosses the x-axis. Now anywhere I go on the x-axis, the y value is 0. So in order to calculate this, I just replace the y value in the function with 0. And when I do that, I find that 2x would be equal to 12, so x must be 6, and so the x-intercept is just 6. Then I can do the same thing with the y-intercept. The y-intercept is where this thing crosses the y-axis, and wherever it crosses the y-axis, the x value is going to be 0. So if I replace the x in my function with 0, I would find that the y value would then have to be 4. So no slope involved on this one. I just find my 2 intercepts, and then I can connect them again with a dashed line. And now I have my 3 regions. I have the greater than section, I have the equal to section, and I have the less than section. So what I'm going to do is shade in the appropriate regions based off of my inequality. I know I want the greater than section, this area right here, and I want the equal to section. So that dashed line I'm going to fill in as a solid line. And now I have graphed that inequality. Again, just graph your boundary condition, shade in the appropriate places. Finally, I want you to see that this can be done with a quadratic as well. So let's look at the inequality. Y is less than or equal to x squared minus 2x minus 3. So this is a quadratic equation, or inequality in this case, that is written in standard form. So the first thing I need to do in order to graph this is to find the vertex. So if you'll recall, the x-coordinate of the vertex is going to be at negative b, or I should say the opposite of b, over 2a. So I really need to identify a, b, and c from this equation. A is going to be 1, b is negative 2, and c is negative 3. So the x value of my, or the x coordinate rather, of my vertex is going to be the opposite of negative 2 divided by 2 times 1. Well, the opposite of negative 2 is, of course, positive 2. 2 divided by 2 is positive 1. So the x-coordinate of my vertex is 1. Now, in order to find the y-coordinate, I have to substitute that x-coordinate back in. So I replace all the x's in the function with 1. So I would get 1 squared, which is 1, minus 2 times 1, which is minus 2, and then subtract 3. So 1 minus 2 would be negative 1. Negative 1 minus 3 would be negative 4. And so my vertex is at 1, negative 4. Now, in order to draw a quadratic properly, I need 3 points. From standard form, I know I can also find the y-intercept very quickly. It's just c. So in this case, I would just draw that point there at negative 3. And easy enough, if I want another point, I can just reflect that across the axis of symmetry. So I would go straight across until my point is over the vertex, and I went 1 unit away from the vertex in that direction, so I go 1 more in the other and just create the mirror image of that point. Now I'm going to take and very carefully sketch that curve. If you need to add more points, remember the pattern that as you move away from the vertex, for every space away from the vertex, you move up that many spaces squared times a. And you will get a graph that looks something like this. Again, it's dashed, it's not filled in. We're just looking at the boundary between my 3 regions, and now I have the area where the y values are greater than that quadratic, equal to that quadratic, and less than. Now I'm most interested here in the area where the y values are less than x squared minus 2x minus 3, and the area where they are equal to that. So I've got to shade in that dashed line as well, and when I do, this is my inequality. So notice that even though it's a curve instead of a line, it's still that exact same pattern as we did before. So recall, in order to graph an inequality, I graph the boundary, shade in the appropriate regions according to the inequality. Practice hard, and good luck, my friends.